Hey guys, today I'm going to talk to you about the effects that lift and drag have on the aerofoil, aeroplane, when the angle of attack or the airspeed is increased or decreased. So, today I'm going to be helped by my trusty whiteboard. Hopefully my graphs aren't too bad for you, and I just want to let everyone know that the numbers that I use today aren't for all aircraft. I'm using the numbers and the graphs for a 172, Cessna 172. It's a good aeroplane to use because it's a very broad aeroplane, but each aircraft type is different and will have different numbers. And what I'm using today is just a general use for general aviation. Alrighty, so let's jump into it. So I'm going to firstly talk to you about the drag and airspeed relationship. So, no time wasted. I'll jump into it, drawing a graph. Hopefully the graphs turn out not too bad for you. My whiteboard's falling over. So, I'm going to write this up as fast as I can, just so I can talk about it. Oh, drag, my bad. So, drag, airspeed. Airspeed increasing, drag increasing. Draw a text down. Now, there's a couple of drags that I'm going to use just quickly. Now, I'm sorry about my graphs may not be exact, but for the purpose of this exercise, it will do. So, we're going to talk about this one first. This is called induced drag. I'll write it down for you. Induced drag, and that, very briefly, is a byproduct of lift. So, you can't have lift flying without induced drag. Secondly, this line here is parasite drag, and that's made up of three components that fit into the parasite drag, which is form, skin friction, and interference. I won't go into that, just you need to know what they are, just for the overall. And this one is the most important one. Total drag up here. Sorry if you can't see that clearly. But that's the total drag curve. And the important thing to take away from this is that point there. And that point is where the parasite drag and the induced drag meet, and it is also the point where the least amount of drag is on the aerofoil. So, that has a couple of meanings. A good one that comes from that, it is related to our lift, but that is in the Cessna 172 is our glide speed, and that speed is 68 knots, and that is because that point there is where the lift and the drag curve are at its furthest apart, and the lowest drag, it's not the highest lift, but it's the most furthest apart. So I'll show you a bit more details in the other graph that I'll draw, but that's a really important concept to have. So, let's get back to this one. The second part that I want to look at is the relationship between angle of attack and the lift and drag there. So, I'll just run this out real quickly. Ajax spray and white. Handy thing. Let me just get rid of it all. There we go. So, the easiest way for me to explain this is to draw a couple of wings. So just imagine this as our wings. Relevant airflow is coming from that direction. I know it's not drawn to scale, so please bear with me. Say this is 4 degrees, this is 12 degrees, and this is 16 degrees. Now that's an important number, and we'll come to that. But firstly, sorry, my computer went off for a sec. Firstly, we need to talk about the relevant airflow coming in. So if your wings are at 4 degrees to the relevant airflow, not the way that you're projecting, but the relevant airflow, the air is going to be able to smoothly separate and flow behind the aerofoil. And that creates a little bit of lift, a little bit of drag, okay? Now as we get a steeper or a greater angle of attack, going to 12 degrees now, the lift, so that point there, the lift actually moves forward and increases a little bit. And the drag, still there, with the relevant airflow coming in, but much more of an angle now, creating more lift at that. Now 16 degrees is an important one. I'm going to use blue for it. And that point there is where, on average, roughly, 16 degrees angle of attack will produce the most amount of lift but the problem with being at 16 degrees is as soon as you go greater than 16 degrees, let me put one more. As soon as you go greater than 16 degrees, the lift drastically lessens, and that becomes a stall, and the drag drastically gets a lot bigger. And the further you go, the greater the drag will be, the less the lift will be. But the 16 is an important one, and that is where the most lift will happen. And as soon as you topple over that 16 degrees relevant to the airflow, so the angle of attack, that's when you're going to get a stall, and that's when the drag will increase significantly and the lift will decrease. So that's an important concept to have again. I'll rub that off. 2 seconds. Now my third graph is going to be, let me draw it. Oh, almost fell over. Again, this is back to our airspeed. And this is our angle of attack. Angle of attack. So, there's going to be 2 lines on this one. Red. And blue. Now, If I left that how it is at the moment, do you think that'd be right? Definitely not. So, what do you think this point here would be if we're thinking about back to the relevant airflow and our angle of attack? Let's say this is 16 degrees. Okay? Let me just quickly write lift and drag. Now, at 16 degrees, what happens to the lift? Greater than 16 degrees, sorry. What happens to the lift? It nosedives. So at 16 degrees is when the drag will actually, so this line's actually a little bit out of it, but let me draw that again. Be like that, where the drag becomes greater than lift, and that is a problem if you want to stay straight and level, because that is going to induce a stall. That's a serious problem right there for you guys. So just to summarize everything, I'm going to give you another brief overview of it all, but as your airspeed increases, your lift will increase. As your angle of attack increases, your lift will increase. As your as your airspeed increases, your drag will also increase. And as your angle of attack increases, your drag will also increase. Until, going back to that very first graph where drag actually decreases up till 68 knots for a 172, and then will skyrocket up from there. But in general speaking, they go hand in hand with each other, and if you could find an aircraft that has no drag, you'll be one lucky guy. But unfortunately, every aircraft has drag simply because the aeroplane is there, the aerofoil's there. That's back to your parasite drag and your skin drag, your skin friction, all that kind of stuff. So, just going back to the argument, state where the lift and drag of an aerofoil will increase, decrease, changes in the following: airspeed and angle of attack. I've covered that for you guys. If you have any questions, feel free to email me. Have fun. See you guys.